Alrighty. Does everybody have the thing open?
Yeah.
All right. So we'll start question 1. What is the difference between matched pair data and independent samples? Well, I watched the video on it today, and it was pretty clear. Like it gave the example of like a matched pair or a set of matched pair data would be like the differences between the heights of sons and fathers. And so if you randomly choose sons, then you're forced to pick certain fathers. And so your one sample is like you can do a simple random sample to get like one of your groups, but the second group is like you have to pick that group. You have no other option.
It's dependent on the first group.
Right. Whereas independent, you can do like heights of a simple random sample of men, and then a simple random sample of women, and so you have both of those have they're not dependent on each other at all.
Yeah.
Yep.
Okay.
Cool.
So
The second one, the other three hypotheses were
Nice.
the hypothesis test with one mean sigma that's unknown. So you have the first one that's known, the second one it's unknown. And then you have two different hypothesis tests that the mean pair is a paired data or it's an independent sample.
Right.
And those are the four.
Yeah.
The requirements are normally distributed, and that it's a simple random sample that's taken
Yeah.
to work. The name of the distribution is the t-distribution for those three, and then the null hypothesis and possible alternatives are pretty much like the same.
Well, right. The only difference is then in the matched pairs, you're checking to see like if the difference is 0.
Mhm.
And then the new ones, you're checking to see if the mean of the first sample is the same as the mean of the second sample. That's your null hypothesis.
Yeah.
Yeah.
Cool.
Okay. So in part 2, okay, I can independent samples. One of the professors in the BYU Idaho Math department collect data from BYU Idaho students to compare the mean wages
Uh-huh.
of BYU Idaho male students to BYU Idaho female students. The students from his classes completed a survey which he then used to analyze if there is difference in these ways. So, what is the research question? So the research question is if there are a difference between wages in female and students and male students, right?
Yeah, you can say it's wage.
Wages. Okay. I'm gonna write that. Wage.
So the null hypothesis would be men and women are equal.
Yeah, that the mean wage for men equals the mean wage for women.
Right.
An alternative is that they don't equal each other.
Is that they're different. They don't equal each other, yeah.
So it would be the mean 1 equals the mean 2.
Right.
And then the mean 1 doesn't equal the mean 2.
Right.
Okay, did you guys get the data? Because I tried to click on the link and it froze my computer.
Yeah, I did it. I have it. I can show you. I can just put it up on the screen.
Describe the data collection procedures. Plug in the numbers.
So I put, well, the data collection, that's like, he could have done a survey, or he could have gone to the HR and checked the financial records. Those are the ways he could have got it.
I write a survey. So I think.
He did a survey?
Either a survey. I think on the key it gave us like either a survey or finance. Well, let me see.
The bursar's office.
No, Danielle is right. He just took a survey.
And then in a short paragraph, use summary statistics to describe the data.
Yeah, let me. I'm gonna put my screen. I'm gonna do a screenshot or screen mirror so everybody can look at mine. Okay.
Okay. Hi.
Whoa.
Well, it looks like we're going to be on this for a little while, so I'm just going to try and figure out how to get the numbers.
There.
Right. Yep.
Okay, class survey. Is it the class survey data for SPSS or class survey data for Excel?
Do it for the Excel if you're going to plug it into Excel.
Excel data files.
And then this is the quantitative inference procedures, and then you're going to do it for the 2-sample t-test.
Yeah.
Class survey. Got it. What? It says Excel can't open 2 workbooks at the same time? What does that even mean? Holy moly. Is yours crazy?
Yeah. But it's only
Oh, yeah.
wage.
Yeah, you gotta look for the wage. And then you're only gonna take, so like, hold on, let me pull up mine so I can explain. So on the left side, on column B, it has the females and males.
Yeah, so you just
like at like 97 is where the male starts.
Yeah, I got it.
Yeah, and then wages are at N.
Uh-huh.
And then when you do your graph, you're supposed to do 2 graphs, I found.
Right.
But I don't fully understand why my graphs don't look like theirs.
I'm gonna show you mine.
Okay, I'm gonna stop sharing. Yeah, show us yours.
I think it's this one. Can you?
Yeah, so my graphs kind of look like yours, but they don't look like the answer key.
Oh.
Yeah, look at. I'll show you where the answer key is.
Oh no. Yeah, I don't know why.
Yeah.
It's different.
Yeah, the answer key is like. It's got cool ones like this. I think it's because they set their parameters different. See how there says like $0 to 25 to 50 to 75? Do you see that?
Yeah.
I think that's where it's different. Is my graphs don't have that.
Yeah.
See if I can.
Maybe we need to use. So it's only another form to express, but it's the same, right?
Yeah, it's the same. Yeah, it's totally the same. It's just their x-axis is different than ours.
Okay.
How come there's a couple wage spots without a number?
I was wondering that too, and I'm not sure. Maybe they just declined to say.
I don't think these are real numbers.
So you think we have to get rid of them?
I don't know, because the men's like, oh, I guess the women has 1.
My guess is that when there's nothing in it, it doesn't do anything to it. Like if it said 0, then that's different.
I'm gonna have to pick Morgan up from the school in like 15 minutes.
Okay, well we're almost done
I'll keep cruising with you guys, and then I might have.
Yeah, we're almost done with this though.
Peace out for a sec. We gotta answer all the questions in part 2.
I know, but like everything in part 2 is just looking at my Excel sheet.
Okay.
So I'm gonna screen mirror it again so you can see it.
Oh, it's too tiny on my phone. I guess
really?
it's not.
Okay.
Okay, so 4, what are we on, 4?
I'm not sure. I'm just going to keep this open and you ask the question and then.
All right, what type of hypothesis test is appropriate? Equal to?
So, right.
Are the requirements met for this test?
Yeah.
They look random enough.
They're random and the n size is big enough.
Are they They're evenly distributed because the n size is big enough.
Yeah.
Okay, compute the test statistics, done. State the degrees of freedom.
Yeah, so I'm not sure. They didn't really explain how to do degrees of freedom when you have multiple variables. But the degrees of freedom, as you can see on mine, are 98.263, and the test statistic is plus or minus 1.836.
Okay. The p-value, and compare it to the alpha level. Sorry.
So our confidence level is 0.95, so our alpha is 0.05. And our p-value is 0.069, which is
so it's greater
than. So we don't have enough evidence to refute the null hypothesis.
So make a decision. We fail to reject it.
Right.
Present your conclusions in the form of an English statement. We fail to reject the null hypothesis. Rather than testing a hypothesis, now say you just want to estimate the difference between female and male wages at the 95% confidence level. Create a confidence interval to estimate the difference.
Confidence interval is negative 0.176 to 4.529.
Yep. But I don't know if I changed in mine the confidence interval.
What do you mean?
No. It's okay. I was confused.
Oh, and then this is the graph. These are the two graphs. What other questions are there?
Now interpret the confidence interval you built above.
So we are 95% confident that the true difference between the mean of men's wages and mean of women's wages is between negative 0.176 and 4.529.
Sweet. Take action. In a short paragraph, describe the action you feel should be taken based on the statistical results above. Well, the action is we failed to reject the null hypothesis. So either you'd have to run a bunch more numbers.
Yeah.
Or you just would assume that the null hypothesis is true.
Right. You just can say we're now informed and can tell other people that that there isn't a significant difference between men's and women's wages.
Okay.
Whoa, what was that?
I had to get out of the thing real quick. I gotta go get Morgan.
Okay.
I'll be back in a couple minutes. Sorry, guys.
We're gonna start the quiz.
She had a presentation. It was supposed to go till 9, and it looks like it got out way early.
Okay, we're gonna start the quiz, and then we can help you with the answers later.
Cool.
Yeah.
I'll be back in a minute.
Okay.
Okay. Do you have the quiz open?
Yeah.
Okay, so the first question is true, and the second question is true.
Yeah. Okay, and then.
Okay.
Okay.
What requirements must be checked in conducting a hypothesis test comparing two means with independent samples?
The second one. And
the first one as well. And the mean has to be greater than 0. I don't know if that one's true. I think just the first two.
The test statistic for hypothesis test comparing two means with independent sample is t-score, right?
Right. You're reading 4. Sorry. Yeah. T-score.
Two samples are independent if will be. Oh no, which it's the second one, right?
Right, because if you know the group 1, because you know group 2, then they're not independent, they're dependent.
Yeah.
Okay, cool.
Yeah.
So do we need to use the data file for this one? All right, I can do it.
Dentist. I need to. Is dentist office bills?
Yeah.
I can't open.
Okay.
Oh, yeah, I have.
You got it. Okay.
Okay. So. Okay. So perform the hypothesis test. I want to close all my. Okay. Okay. Entonces, in mine, I show you in my Excel thing.
Okay.
Yeah. Okay. Sorry, my computer is so slow. Okay. So the first group is and the second one.
Which one did you choose for your first group?
Yeah, I choose Idaho Falls Dentist Office.
Okay, me too. Okay, good. Yeah, that works.
And then the second one is the other one.
Yeah, Rexburg.
Yeah. So it's like this. Can you see or?
1 second. Now I can see. Yep.
Yep. Okay.
Yeah, we got the same ones now.
Okay.
So your T-score is negative 0.434. And your p-value is 0.666?
Yeah.
Okay, awesome. So now let's look at the questions. Okay.
What is the
What is
degrees
the
of freedom?
degrees of freedom? Looks like 37.996.
Yeah.
Okay. So we'll go back to there and round. So awesome, 37.996.
And then, what is the sample standard deviation for Rexburg?
Sample oh, for Rexburg, that's variable 2. It's 206.637.
Yeah.
Okay. 206.637. Test score or test statistic was negative 0.434. I think it can be positive also though.
Yeah, I think the same. So it's only 0.434, right?
Yeah, I don't think the negative matters. Okay, then the p-value was 0.666. 666. But should we do 0.667 because it's 5 is next?
Yeah.
Okay. 0.667. Okay.
And what is the correct decision based on this evidence.
Fail to reject.
Fail to reject, yeah.
What was the confidence interval supposed to be? Oh, it's supposed to be 0.9. So we got to change that.
Reject the null hypothesis.
Yeah. Does it change anything else if we go just 0.9? No, it doesn't change anything. It's the same. So we still fail to reject.
To reject?
Yeah, because the confidence level is
Less.
0.9. Yeah,
Uh-huh.
the significance, which is alpha, is 0.1, and we're still greater than 0.1.
Oh, okay.
Oh, but we didn't do. Hold on. The alternative hypothesis is that U1 is less than U2. We didn't change that either.
Reject?
Less than. Oh, no, we still don't.
So the p-value, when it's greater, we need to fail to the reject. When it's less, we
Right.
reject. Right? So what is the sigma?
Sigma is 0.1.
So
Oh, it's not. Is it sigma or is it alpha?
Alpha. I'm sorry.
Yeah, alpha is 0.1. So we still fail to reject. But the only thing, if you look back at the beginning where the information is, do you see where it says the null hypothesis is that the U1 equals U2, and then the alternative hypothesis is that U1 is less than U2? So then we have to go to our Excel sheet and change the type of test.
The type of test?
The type of test, right? Because you have to make it less than.
Yeah.
And when you make it less than, the p-value changes.
Oh yeah, 0.
It changes to 0.333.
So we need to change that in our quiz.
So that was question 9.
2.333, right?
Yeah. And we still failed to reject though. So suppose instead that you had the alternative hypothesis, U is just not equal to U2. So now we'll go back to Excel sheet and change it. So not equal to. Now, what is the correct decision based on this evidence? We have
sufficient evidence that the mean distance will between the two cities are different.
I think we still have insufficient evidence. So I think it's number 2.
Yeah. Because we failed to reject, right?
Right, correct. Okay, so now we'll do the next one.
Freshman.
Okay, so let's read what they're saying. So let U1 represent the mean number of times a month the student from Colorado cooks dinner. Okay. Student from Colorado. That's U1. Let's see. Put that in here.
I can't open that one.
If you can't, that's okay. I can do it.
Okay. Thank you.
And then I can just show you. Okay, so I plugged them in already.
Okay.
And this one, I'm going to change the graph. So this is Colorado.
Mm-hmm.
Okay, so what's the question?
The first one is about the hypothesis.
Yeah,
What
so
is
actually, the other
the
thing though is the first I need to change the significance. So before we get started, so I don't mess that up. So the significance is whereas confidence level is 0.95. So now we have to figure out what the question is. Okay, what is the appropriate alternative hypothesis?
Yeah.
So you suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. So it's not less or
Different.
greater. It's just not equal.
Not equal.
Okay.
Yeah.
What is the test statistic? So now I'll go back to here. So the test statistic is 0.845.
4.5. Okay.
And the p-value is 0.411.
Okay. 1. So what decision you make? The sigma thing is
Sigma is, or alpha is 0.05.
So reject, right?
Fail to reject.
Fail.
Because our p-value is 0.4.
And
the alpha is 0.05.
Oh yeah. It's fail to reject.
So then determine the error of margin, or the margin of error. So it's half of the confidence interval.
The margin of error. So we need to use the formula, right?
I think we can actually just take half of the confidence interval. So if we look at so do you see my screen?
Yeah.
So on the confidence interval right here.
Hold
on 1 second. Hey, what's going on? So the confidence interval right here says, what? That changed. Why did that change? Hold on. So this has to go to 0.95. Uh-oh. Maybe we need to, I thought I did that already. Oh, I think we need to go back because I guess I didn't use this or put this in yet. So our t value and our p value are different. Oh no, our p value is the same.
It's the same t value too?
Oh, so everything's the same?
Only change the confidence interval, right?
Yeah, but why did that change? Huh. Oh well, so I think that we have to go. So if you say 2.214
minus
plus 5, because technically it's 2.214 minus negative 5.147.
Yeah, plus because it's yeah.
So that's 7.361, and then you divide that by 2. And that's the margin of error. So it's 3.6805.
So X0, X81?
Yeah, 3.681. And the lower bound is negative 5.147.
Negative 1, how?
Negative 5.147.
Negative 5 is what? Which one? Oh, yeah. Minus 0.2.
Yeah, and then, so you see where the lower bound is on here?
Yeah.
And then the upper bound is 2.214.
0.214. Uh-huh.
2.214, okay. I'll submit it and see how we did.
Mm-hmm.
We missed one. Oh, see, my test statistic was wrong. I said something different.
In the last one?
Yeah, so what did you have for question 8? What did you write down?
8?
Yeah.
I have 0.434.
Yeah, so it needs to be 0.845.
0.845?
Yeah, 0.845. Yeah, because if you look at mine, see, I got it wrong here. It's because something happened when I pushed enter, like that one time.
Uh-huh.
It gave us the right test statistic. Okay, and then this one.
845?
So it's saying that our test statistic is off.
Or what?
For question 13 and question 8, it says that we're wrong for our test statistic.
Oh.
So maybe we do need to put negative.
Negative?
Yeah, so maybe you should go back. You can leave. So for question 13, just do negative 0.845, and then you should change your question 8 back to negative 0.434.
Negative 0. What was negative 0.434?
34. Yeah, and that's for question 8.
I'm going to submit and which one?
So everything else is right besides 8 and 13. So do you want to try to submit it with the negative?
Yeah.
Okay.
And it's submitting. So yeah, it's that the reason. I get we get 100%. So
Yay.
yeah, it's a negative thing.
Okay, cool. Well, I can just I'm just gonna open the test or the quiz on a different page, so I can just do it, and then I'll help Andrew out when he's done. So
okay.
I think we're good for today.
Okay, thank you for everything and for the patience too.
Well, you kind of help us out when we always forget what we're supposed to do, so it's all good.
Thank you.
Mm-hmm.
Yeah. See you Thursday, right?
Yeah. Yep.
Thank you.
All right. Have a good one.
Bye.
Bye.